Attorney, and I am on the Google Cloud community team. I've been counting down the minutes for this session. I'm beyond excited to be here. Today we'll be discussing LangChain on Vertex AI with Anna Whelan and Christopher. Just a few logistical pieces before we hop in. Please utilize the chat. We'll get to Q&A at the end of the session. And without further ado, I'll pass it off to Anna and Chris.
Awesome. Thank you so much, Willie. We're very, very excited to be here. Happy to have you all joining today. Thank you for taking time out of your busy day to join us. And I promise in exchange for your time, we're going to give you some amazing concepts related to AI agents in Google Cloud. We're going to give you some sample code, resources, documentation, and we're going to have a lot of fun doing it. And so today we wanted to take some time to talk about something that went public preview at Cloud Next in April, about 2 months ago. And it is called LangChain on Vertex AI, or Reasoning Engine. We're going to use those interchangeably in this session. So today I want to talk with you, Anna and I want to talk with you about building and deploying AI agents with Reasoning Engine. And really what this is, it's the best way, in our opinion, to use LangChain together with Google Cloud. We think they're better together. We've been working very, very closely with the LangChain team and all of the open source activity around it. And we're really excited. Before we dive in, one fun fact when I was putting this together is the LangChain logo. Anna, do you ever notice the LangChain logo, right? It has a parrot and a chain.
Yeah.
I never really thought about that until I was putting this together, and I put those together and I thought, why is there a parrot? So usually there's no python, there's no snake, you know. And so I looked into it, and I think the answer that I came across was that in AI agents and natural language research and so on, there's a phrase called stochastic parrots. And I never heard of that before. I had gotten into the habit of calling LLMs random word generators, kind of like the Markov chains of a decade ago or so. So anyway, the logo for LangChain actually means chaining together stochastic parrots. And stochastic parrot means like you have a thing that's generating words probabilistically, right? So I thought that was pretty cool. So I'm very, very happy to talk about chains of parrots with you all in Google Cloud and chaining them at scale securely. And I think we're going to have a lot of fun here. So I really appreciate you all joining. And this is one of the first sessions publicly where we're talking about all this stuff. So we look forward to laying down a lot of concepts and then going from there with you all on this journey of like, what does it mean to build and deploy AI agents? So with that, let's get right into it. And of course, we have Q&A at the end. If you have questions along the way, please post them in the chat and we will get to them at the end. We had some pre-submitted questions as well, so thank you for that. So without further ado, let's introduce ourselves. Anna, go ahead.
Yeah, so hi, my name is Anna Whelan. I am a product manager here at Google Cloud. I'm located in Chicago, and so I've been in the AI space for about 5+ years now. Started off as a data scientist, then as an AI engineer, and now as a product manager. Little fun fact about me is I guess I love playing games. I've been currently in a huge cribbage kick, so that's been a lot of fun. Also euchre as well, so.
Awesome, that's good to know. Thank you, Anna. And so here, so I'm Chris Overholt. I work as a developer advocate in Google Cloud. I specialize in the AI and ML product space, so I've worked on anything from document AI to Vertex AI Vision. Last year, funny enough, I was working in Dialogflow CX a few months just before the Gen AI storm hit us all and kind of flipped all of our worlds upside down. So since then, I've been working a lot in Gemini and function calling and reasoning engine. I like to think of all of those buzzwords as like LLMs doing cool things, because I think LLMs as stochastic parrots or word generators is really cool. But I like to go a little bit further and say, like, can we make LLMs, learn about like maybe a RAG implementation and learn about things that they weren't trained on, or maybe can they solve complex problems? I think it's the engineer in me that likes that about LLMs. So I'm based out of Austin, Texas area. I've been working at Google for 2 years, and before that, I worked a lot with open source communities and companies like Anaconda and RStudio and Coiled. So I love data science and seeing how we got to where we are. Fun fact about myself is I used to set things on fire for a living legally. And so I worked at a government research lab called NIST here in the US. And we did fire research and metrology. And so we would set up big houses or warehouses and set them on fire. And then we would model them in computational fluid dynamics model to figure out, like, is the math right? Is the physics right? So it's kind of cool, to come. That was a couple decades ago. And then here we are with AI agents, like, doing these autonomous tasks. So really, really love to see how this is going, and looking forward to getting into it with you all. So today we're going to walk through a number of different topics related to AI agents, and we're going to bring them all back to Vertex AI and LangChain. That's the theme of today. And so first thing, we're going to compare approaches. I'm going to do some live coding. I'm going to see how many things I can break and how we can build agents. Number two, we're going to walk through how we got from generative models or LLMs to AI agents. And that'll happen very quickly, say in the last year or less. Then we'll talk about challenges when building agents. You've probably run into challenges with LLMs. And of course, when you get to an agent, all your problems don't go away. They just change into a different form. And then we'll get into an overview of reasoning engine, what it is, what it does, how you can use it as a developer, why I as a developer, and I think you will too. And then we'll look at reasoning engine in action. And so we're going to look at really detailed use cases of information retrieval or basically LLMs doing different kinds of things and patterns that you can take with you and make your own. And then lastly, we'll end with a summary and some resources like sample notebooks, documentation, and places to file feature requests and bug reports that we can't wait to hear from you. And I promise we love feature requests and bug reports equally. Anything from our users is always good news. So, okay, so let's get into it and talk about motivation, comparison of approaches. As I was putting this together, I thought to myself, I've been banging a lot on agents and AI agents. How can I represent the complexity of this to a developer and what it means to build an agent today, sort of the hard way or doing it on your own versus doing it with a structured approach like reasoning engine. And I thought about how to do that. Like, how can I put that together in slides and show different things? And I thought, you know what? No slides. I'm going to live code and like build an agent and see what we can break and see actually the intricacies, because this is what you all do all day. This is what I do all day. And so let's try to break some things. So let's build an AI agent together. Anna, you can help me make sure I'm getting the requirements right and stuff. As an engineer, I'm going to hawk things, but you can make sure to keep me in line as a PM and say like, oh, don't forget functionality A, B, C. So let me switch over to my desktop and we'll start coding. So let's say build an agent. So what I'm going to do first is I have, let's see, just so you know I'm not cheating, I have about 50 lines of boilerplate code here. That's a Streamlit app. Very, very simple UI. I'll spin it up in a second. And so let me put in, I wanted to give myself some kind of UI here so that you wouldn't have to watch me in the terminal curling back and forth. So let us run this and get to the right place, and then we'll start coding and breaking things for sure. Okay, so we'll do Streamlit run first attempt. See how well this goes. Okay, awesome. So there is our Streamlit app, and it's up and running. And right now, let me just give you a quick view of the code. It's very boilerplate. It looks like what comes out of the Vertex AI Studio. We're going to talk to Gemini 1.5 Pro. I gave it system instructions. I thought I'd have fun to make sure they're working. You're a pirate that gives life advice. So I just wanted to make sure, sometimes you never know if it's working, right? I think we'll be able to tell if it's working correctly and obeying that. We have generation config, safety settings, standard stuff. And then the bottom here is a few lines of code to chat with Gemini. All it is a few Streamlit primitives, right, that help you form a chat interface, take in user prompts, and so on. And this line 47 is the important one. This is where we send the message to the LLM, get an answer back. Okay, so this is not yet an AI agent, but let's see if it's at least works. So let's say hello, and let's see if the demo gods are with me. Oh, great. Ahoy there, matey. What brings ye to old Captain Advice? Great. So it looks like it's working correctly. And I could say I'm having trouble sleeping these days. It's something you could advise just to make sure our multi-turn and all that's working. Great. Shiver me timbers. So it gives us to get your sheets in the knot, fog bank rolling. So, looks like it's working. So what I want to do now, oh, go ahead.
Oh yeah, no, I was kind of curious. So
Yes.
it seems like you
Yes.
have the LLM, but I assume this maybe
Yes.
your next step is adding on toolage and connecting it to outside information.
That's exactly right. And that's a good point, because we're doing this like right off the bat in this session, right? And we haven't even defined an agent. So it's a good idea to think about, like, what are we doing? So maybe we want this to like reach out to some kind of service and retrieve information and summarize it back as part of an agent loop, right? So that's a good idea. So now that we have this, you're absolutely right, Anna. Let's think about, what do we add now to add an agent? So I'm going to go to LangChain agent, and it looks like there's a docs page here. Quick start. That sounds like a good thing I should probably do in this session. And so if I go through here, yes, there's tools. They have an example of a search result tool. Looks like they have agents and invoke the agent. Okay, that looks like a lot of code. So I am going to go over to my friend gemini.google.com, and I am going to ask it to write code for me. So let's see if that can get us started. I'm going to say write Python code to, let's say write Python code. Let me bump the size up there. That uses LangChain agents to talk to IMDb. Maybe we'll make like a movie agent bot, right? That you can like talk to and ask about movies, what year they came out, what their plot summaries are. So write Python code that uses LangChain agents to talk to IMDb as a tool, and we'll see what happens. So first step is, I have my Streamlit app. I've hooked it up to Gemini's chat modality. So we have all that working. But right now we're only using information that the model was trained on. And we're doing kind of this one conversation turn equals one response thing, right? And so here we go. We have some code here. And you know what? I'm just going to let it finish doing its thing. And we'll copy that over. And let's see. We'll get Anna, can I get a security review on this? Great. Thank you. Okay, cool. All right. So moving on, we will paste this in here, and let's look at what it generated here, right? So we have LangChain code, which is a good start. Don't know where that search came in there. IMDb search tool. So okay, so this is kind of interesting. I have an IMDb search tool. That's kind of what you were saying, Anna, right? Like something that reaches out. For some reason, Gemini wrote with a DuckDuckGo search and some weird things, right? But I can kind of see the general idea of what it's trying to do. It's trying to search, summarize, and then instantiate an agent. And it looks like it uses a zero-shot React agent. And then an example, tell me about the movie Dark Knight. So this kind of makes sense. And I think I'm done. I think I built an agent. I won't spend another hour here trying to hook this up and stuff, but I just want to give you an idea of, you start with Streamlit, we have an agent. So I think we're done, Anna, right? Like we can probably end the webinar and I'll go home.
No. So
No?
I would say some other things you'd want to maybe consider are like, your agent settings. You have memory.
Yes. Memory, good call. So basically you're saying that even though I'm using the chat modality in Gemini, like that's my need to actually add that to my agent to have memory. You are totally right. That's why you're the PM, and I'm just slinging code over here. And so let's say like LangChain agent memory, memory and agent. Cool. So there we go. We have memories and agent. And so, okay, I see. Yeah, there's like a simple way to do a chat message history. And I know they also recommend using Runnable with message history. Let me save that and I'll put a to-do in or something. I'll do that later. To add memory. Cool. So I'll add memory and then our agent will be like production ready, and then I can deploy it and our startup will make all the money. No?
So I think some other things we want to take into consideration are, deployment, logging, you have security, scaling, a whole bunch of other things to make this really holistic.
Yes. Oh, that's a good point. I'm running on my local machine. Yes. So let me, okay, you know what? So I'll say like deploy LangChain agent, and maybe I'll make some notes and things. And after the session, I'll go back and make this production ready. Can't take that long, right? And so, okay, here's a page in LangChain about deployment. It looks very comprehensive. Also looks very long. I shouldn't be worried though, right? So with monitoring, fault tolerance, cool. I can do those things. Load balancing. I could spin up a load balancer in GCP. self-hosted, spot instances. Oh, infrastructure as code, right? I should probably like put all these primitives in something like Terraform, CI/CD. I need to test this. You know what? I'm just gonna make some more to-dos, and this will be production ready by, what did I say? 1 week? Give me like 3 weeks, and we'll have it ready. So add, deployment, load balancing, etc. Okay, that's pretty good though. So I think we have an agent, and I think I have. But you know what, Anna? Before I go, I'm gonna make one more to do. Plan vacation. And you know what? Let's push this agent thing to like next quarter. I don't. That sounds like a lot of work. So basically, let's recollect ourselves now and go back to our slides here for a second. And so that was like one example of that. When you're trying to build agents, we ended up in the LangChain docs, and sometimes you might also end up in other docs, Google Cloud documentation on deploying. You might end up in like dependency management. And before you know it, you have 50 tabs open and you forgot what your agent is supposed to do. And it's speaking pirate speak to you and you don't know what to do. So I think the point we're trying to make is that was harder than I thought. It's easy to prototype and build things with open source. Like we see tweets and blog posts and we build it. But you're right that, just the basic functionality of chat plus memory does not make a production ready agent. But to your point, I want to like experiment, but I also want to have a quick path to production, right? So let's try that again. We're going to start over, take a deep breath, and start with reasoning engine this time. And when I say start with reasoning engine, it really just means a happy path. There's no like, you're not going to drop in reasoning engine instead of LangChain, but hopefully you'll see it's just a happy path for doing what I just did in a very structured, linear, composable, modular way, all the things that us developers love. So let's try that again, take 2. And let's go to our Streamlit app, and we'll go to second version. Okay, so this is the same Streamlit app with the same pirate that gives the same life advice. And so we'll start there. And I made a few notes up top here because this is kind of the reasoning engine way, right? So, and we'll talk about this in great detail in the session. So don't worry if it doesn't make sense yet. So we're going to define a model, we're define functions, we're going to define an agent and deploy an agent. I like that series of steps. It keeps me in line. So let me spin up our second attempt. Get that running. Great. And then what I'm going to do now is I'm going to go to one of my favorite repositories, the Generative AI repository on GitHub. There's a link here at the end. Don't feel like you're going to miss out on this. Inside of here, there are sample notebooks for Gemini and many, many other things. There are some for reasoning engine that we wrote for you all to use and take as your own, and use it to get a promotion, use it to build your cool next thing. Take all of our code, please steal it all. So I want to go into the intro notebook, and just for the sake of this first part, I want to just build the agent. And so we'll come back to all these concepts. But I'm going to scroll through here and I see, okay, define the model. That looks like our steps that I had in my script. So first thing, let's define a model. And of course, we have GA'd Gemini 1.5 Pro, so I'll update that. And then next thing, define Python functions. Okay, so this is where I can just define a function. And I think that's what you were saying, Anna, like a tool, right, that does something. Mm-hmm. So I'll say get exchange rate, retrieve the exchange rates. So this is just a Python function. There are no reasoning engine, Vertex, LangChain in there. This is just requests calling to a currency exchange API and returning the JSON. Next up, we have defining an agent. Oh, interesting. So this little 5 lines of code tells me that I'm defining an agent. I see something called reasoning engines.langchain agent. That looks very interesting to me because this looks super short and sweet. And so I'm a little bit skeptical, but let's see what happens. And then I can probably test this agent locally. We'll do that. And you know what? Let's kind of see where we're at now. I'm just going to run this in Python and about the Streamlit part for a second and just see if we can get this running. Let's do Python reasoning engine and we'll see what happens here. Of course, I didn't import it, so let's do that. So this reasoning engine went public preview in April during Cloud Next. And so if I go into the preview namespace, I can import From Vertex AI Preview, import reasoning engines. There we go. Let's see if our script is happy now. Wait for it, wait for it. I think I'm still, oh, you know what? I may have to define, oh, you know what? I didn't return anything. Let's return one thing and then we'll move on. Let's print the agent response like so, and print the response. Okay, let's see if we get a response here. So basically what's happening right now, oh, cool. So it looks like we do have a response. This is all messy JSON and stuff, and we could took this in the Streamlit, but I'll save you all the time. But basically we have the input. What is the exchange rate from, let me get the text up so you can see it. What's the exchange rate from US dollars to Swedish currency? Output, the exchange rate is this. And we even passed the intermediate steps that showed, okay, I'm going to invoke this get exchange rate. I promise we have nice tracing. I just want to show you this like in a very hacky way, right, as I'm building it with you. And so it looks like called out to that API, and then Gemini gave an answer. And so we just built an agent. And the last thing is I can actually deploy this agent here by telling it reasoning engines create and passing a list of requirements. So I could put that in here, and it's going to basically take this agent class that I've defined and including the tools and serialize that and put that all into an endpoint. And so now I can just talk to that endpoint and all of the agency stuff happens. I can pass that to my front end team. I can hook it into Streamlit. And it's a really nice and modular way to do this. And so hopefully you saw the difference between like the two approaches of what does it mean to build an agent from scratch with no help? What does it mean to use a structured framework like Reasoning Engine to do that? So that motivation brings us to our next topic. Anna, what did you think of that? How did that all come out? Does that look like what you see developers and users deal with every day?
You know, I see a lot of different use cases kind of for agents, but this is definitely one of the most, very simplified, but it's definitely great. You know, we've gotten reports of people taking, 500 lines of code and just reducing it down to, 20, 50. It's great.
Yes, totally agree. And a lot of people too, as we get into this, like a lot of people say like, well, what is this exactly? Is it a new thing? Does it replace LangChain? It doesn't. It's literally taking all of the messy steps and putting them into structure. So what we like to do at Google, so you can productionize these agents, deploy them. You don't have to worry about scaling, security, all that stuff. And we hope to give you the composability there is not just for convenience. It's to help you as a developer build this in order as you would any kind of application and make sense of it without having the Gen AI like rip apart all of your test cases and debugging and all that. So now let's talk about from generative models to AI agents. So in the early days of last year, there were only models. And we had Palm 2, we had the text bisons and the chat bisons. And really the paradigm here was that this was a new thing, and it was a black box, and it was a very big black box. And so inside of this, we could ask questions like, what is the pixel tablet? And it would answer as our random word generator or stochastic parrot does. And we weren't sure if it was right or not. Like it looked very syntactically correct. But the experts in the room would call out like, actually, that thing that it said was very confidently is very wrong. And that's okay, right? These are models. They're approximating reality. They use neuroplasticity, right? This is all part of how LLMs work. But left alone, the quick realization was everything came crashing down of like, oh, I can't throw out my old architecture and stack and just replace it with LLMs. That's probably not going to happen. Where did we go beyond models? We did a lot of cool things. You probably had it write funny poems or letters and descriptions or summarize emails. Then a new pattern emerged called RAG, or retrieval augmented generation. You've probably, if you're like me, heard this millions of times since then. And everything's a RAG. RAGs are everywhere. There's a million ways to do RAGs. There's even probably a dozen ways to do RAGs just in Google Cloud, using different primitives, different services, depending on what you care on. But the basic idea here is instead of just making calls to the model and getting back words, we add in an extra step, and that is the retrieval and augmentation step. And so we prompt to the model. We also call a vector database, usually with the same prompt or some rewritten form of it. And so when we say what is a pixel tablet, then we'll like search a vector database, usually with embeddings, for things that look similar to that. And the nice thing is semantic search and vector embeddings give us a really rich top K answers. We feed that into the model, and then it comes back with an answer. So this is really, really nice pattern. You've probably seen this many different ways, or maybe you've built one yourself. You can build these things with Chroma, Pinecone, matching engine, which is now called Vector Store, Vertex AI search. There's so many ways to build this, and LangChain has a lot of primitives for it. Google Cloud has some tools. Llama Index on Vertex AI is a recent one. Anyway, lots of stuff out there for RAGs. However, the next thing we quickly realized was that this doesn't solve all our problems, but it gives us a new problem of RAGs have limitations too. We don't know, like it certainly reduces hallucinations, but now we have to treat something like, is it in the vector DB? Is it not in the vector DB? How do we know that? And also RAGs is usually almost always a two-step process, the retrieval and then the generation. There are some fancier RAGs you can do with checks and post checks and maybe calling out to an API or calling to BQ. It doesn't have to be a vector DB, but this RAG is almost always for the purpose of information retrieval, right? Where you're trying to summarize and learn about a thing, help customers, help internal employees, right? The limitation is, how do I actually things and solve hard problems? Like if I ask a RAG implementation, solve this Sudoku puzzle, it may be able to look that up, but it's trying to do that all in one shot. And so what do we need to add to our application at this point to give it a bigger brain? And that's where agents come in. And I will just say right now, there is no hard definition of what an agent is. So please don't try to make one or take away or argue. I won't argue with you on that. But what I will say is that agents add an additional reasoning capability to your application that wasn't there before. And so when you start to stack these pieces together, you say, okay, I have a model. I'm, instead of giving it like a retrieval only tool, I'm going to give it a general tool. And that general tool can, like on the right side, these different boxes can do a search. It can call a vector DB. It could call Wikipedia. It could call a product database. So now when we send a prompt, it goes into our model and it goes into our, what we call our reasoning loop. And that reasoning loop is an agent that can be a React agent or a reflection agent or one of the many other types. And that is going to make a decision about which tool should I use and how should I call it. But not only that, it's actually going to make an observation and have a reaction, and it's going to have a loop like a human would of like, let me try to poke this and see what happens. Let me try to delete that and see what happens. And so it's this feedback loop that makes agents really powerful, because now you can have something that's stateful, has history, can use tools, and can solve problems. And so that's where things get really interesting. And I'll leave it to you in future sessions. We'll get way more into like, what does it mean to be an agentic task or an agentic flow? What does it mean to have agentic pipelines? But just for now, just know that an agent is like a smarter version of an LLM or even a smarter version of a RAG that can do more things and solve more problems. So all of that being said, this is, if I were to say the definition of an AI agent today, I would say it's an application, that's the deployed part, that uses a combination of a generative model's capabilities. It uses tools to connect to the outside world, and it uses higher level reasoning to achieve a desired end goal or state. And so those four boxes on the right are the model, tools, reasoning, and deployment. And those are actually really key concepts when you're trying to build and deploy agents in production. And so keep that in mind, because the rest of the session, we're going to hammer on that with concepts and examples to bring that home. So with that, Anna is going to take over and talk about some challenges we've seen in the world in the past year or so with building agents today. Yeah. Go ahead, Anna.
So as you heard, like agents are a great tool and they can really help with a lot of complex problems. But with that, of course, as you saw earlier, there's a lot of challenges when it comes to building these agents. So if we take a look, just based on what we saw earlier today, there's limited control and customization in some of the off-the-shelf solutions. So, Google has some products themselves, but even then you might find yourself trying to customize or add certain abilities, and you're starting to build this kind of Frankenstein product. Another thing is you're having long timelines when moving from prototype to production. So, typically if you're using certain tools, you may be having to write a lot of YAML files or Docker files or maintain these other infrastructure, components. And that can kind of reduce the time that you're actually going from your local code to production. So, when Chris was saying earlier, this is going to take, months to make, like you could definitely shorten that span. Another thing is you need to really consider the fact that you're building these for maintainability and a modularity at all layers. Like that can be difficult. You end up with a lot of spaghetti code. It's not very maintainable. You have kind of this black box of model, so there's some lack of understanding. And so what we've seen kind of over the years is a lot of times customers will come, they'll start with something, they'll start building it, and they'll slowly realize with time, it's great initially, but then it's just harder to maintain. It starts to become outdated, and just slowly, the product isn't performing as well as they'd like to. And then the last thing is what we were saying earlier is that you need to make sure that you're implementing enterprise-ready requirements. You need to make sure you have security considerations, privacy considerations, logging, all these other things. And that just kind of adds another, again, layer to all the complexities that you're having here. So even though, AI agents are great, there's a lot of complexities that go into actually building them. So I guess what are some of the alternatives that are available today? Well, as you can see here, we have a little bit of this grid to kind of break it down. We have 4 options on the top. We're doing kind of a build versus a buy solution. And then you also have your kind of out of the box or a custom. So in the build out of the box, that's just using your typical open source frameworks such as LangChain or Llama Index, kind of just as they are. If you're kind of looking at your out of the box buying solution, I'd mentioned those earlier. We have, inflexible pre-configured solutions. There are a lot of products out there at the moment that you can use. Google actually has some of them, but you're going to run into, issues with maybe hidden prompts, solutions. And just again, if you're trying to kind of break into that, you're going to find it difficult to actually incorporate any customization. Then if we're looking at a custom build option, that's using maybe a DIY homegrown framework or something like that. And again, you're going to have to do a lot of maintenance and just building on your own. And then the last option is if you're doing some sort of custom buy solution, you could essentially go to a consulting company or something like that. Google has one of its own, and they could essentially build out something for you for your custom solution. But then again, you may not, once they hand it over to you, you're not really sure maybe how exactly it works in terms of maintaining it. It could be a little bit more difficult and confusing. So we're going to be focusing a little bit more on the out of the box solution and a little bit in between this build versus buy. Instead of having to think about writing all this code from scratch versus just getting a simple solution, we're giving you kind of something in between, something that's still configurable and maintainable, but it does a lot of the heavy lifting for you.
That's great. I don't know if, sorry to interrupt, but as I was looking at this and talking with you yesterday, I thought about this build versus buy a lot. And a lot of developers, including folks on this call, may have questions like I did at first of why LangChain, why open source? I've heard things ranging from, is LangChain production ready? Can we actually deploy that? And should Google come out with its own? Should we use something else? Do we have to rewrite it from scratch to do that? And it's really interesting. I wonder, have you ever heard of the book, The Cathedral and the Bazaar?
No.
So that when I look at this slide, there's the left and the right. It's a book from maybe 30 plus years ago, and it talks about open source versus enterprise software. And it's a really interesting read. You can probably read it in 1 or 2 hours by folks back in the Unix days where open source, there was a big fork in the world of what was going on. And so it's funny because the build here, the out of the box, the open source would be the bazaar, where it's crazy things going on. And you probably read things about, LangChain quality and all this. And Google has a lot of open source projects too, right? And they're really hard to maintain. They move fast. And then on the buy side, you have the cathedral, right? The thing that's being put together. It's being put together over years. It's like, don't touch it yet. It's not ready. And it's a really interesting read because as developers in the world today, like we can't just buy something off the shelf and it does everything we want. Like we resist that. In fact, right, we want customization. We want the control to do that. At the same time, we all have day jobs, and we probably can't spend the next 2 years like writing our own LangChain or Llama Index on our own. And so I think it's a really interesting thing that you said, like we want something in the middle. And what I hear a lot from developers is they want like something off the shelf, whether it's open source or commercial, that gets them 80% of the way there, and then they can drive that last 20%. And so that's exactly what we're shooting for. Like we hope that what we're giving in Reasoning Engine is on both the build and the deployment side gets you along the way there, and you can focus on the cool stuff while we handle the kind of the boring stuff, the scaling, the security. Does that sound right, Anna?
Yeah, no, definitely.
I love it. Yeah, I love this comparison. Thank you.
Sure. And so kind of with that, you know, we kind of want to go here and just kind of introduce Reasoning Engine. And just kind of, it's currently our, as you said, our middle solution for overcoming some of those challenges that we discussed. So Reasoning Engine, essentially, you know, it enables Gen AI developers to develop, deploy, query, and manage agents and frameworks on Vertex in a secure and scalable way. Something to note about this is that we are supporting really any framework here. So, you know, that could be LangChain, Llama Index, your own homegrown framework, kind of whatever it is. But then we're also making sure that we're doing this in a scalable and reliable way with being integrated into like the Google Cloud ecosystem. So anything else you want to add to that, Chris, before we jump over into a side-by-side comparison?
No, I think that's lovely. And it's kind of funny how hard it is to write one sentence about a product like this that does so many things and agents, you know, and so we don't, so I encourage you all to think with us that like this is us at Google working through problems with developers like you and coming up with these definitions. And please don't take our word for it. We want you to try it and break it and tell us like which one of is this true? Is this statement true? But I think I've been really enjoyed working with you, Anna, over the last few months of like trying to nail down what is this thing, and can we make developers have, you know, happier and better experiences when working with things like this.
Definitely. So yeah, Chris, do you want to walk?
All right.
Yeah,
absolutely. Yes. Demo time. I always like to break up these sessions with some demos. And so I'm going to flip over in a second to this demo app. It is a public demo app. I try to publish everything I do, no allow list. It's all out there. So it's LangChain on Vertex AI.web.app, deployed on Firebase. And so if you go there, you will see something like this. And you too can play with Reasoning Engine. And so what this is, it's like a JavaScript front end, and we have a few different prompts and use cases. And on the back end, there's a Reasoning Engine agent that's waiting to answer the questions. And it's kind of interesting. If you're as skeptical as I am as an engineer and developer, you might think you probably have 3 agents behind the scenes that are like when you switch tabs, like you're sending it to that agent, so it only does that. It's not true. There's one agent behind the scenes, and it has 3 tools. It has a tool to look up currency. It has a tool to look up a document search in Vertex AI search, vector database, and then it has a YouTube Q&A, which uses a Python library to grab transcripts from YouTube. And based on the prompt only, it will decide what to do. So Anna, have you ever worked with an LLM like an AI Studio, and you ask it a question like, I don't know, what events are coming up, and it gives you that answer of, I'm sorry, as of whatever date, and as soon as you see that, your brain shuts off and you just want to like get the rest of the day off, and you're like, oh man, it's frustrating, right? And so these models are so powerful, but you ask a simple question, it reminds you that they are not online, they are not thinking, they are the stochastic parrots, right, that we talked about. And so let's try to send this prompt and say, what's the exchange rate from US currency to Swedish currency? And let's compare. On the left side is just Gemini, just the Gemini API in Vertex AI. On the right side, we're talking to the Reasoning Engine endpoint, which of course is still using the Gemini API in Vertex, but it has tools, it has an agent, it has LangChain. And so the left side says, I can't give you the live exchange rate.
We may have lost Chris a little bit there.
Oh, yep. Can you hear me okay?
Yeah.
Oh, sorry about that. Yes, thank you for letting me know. I was probably talking to myself. How long did you lose me for? Sorry about that.
Oh no, we were just getting into, on the right side here, we actually have connections to essentially this external data, and we're actually able to pull like.
Yes. Okay. Awesome. Thank you. So on the left side, we have like limited knowledge. I can't provide you the live exchange rate. On the right side, our agent actually reached out to the currency exchange API, got that information, and then synthesized it back to natural language. So the really cool thing here, and we'll look at this more in the code when we get into that in a minute, is we're going from natural language prompt to like structured data to be able to call APIs. We call those APIs, we get a JSON response, and then we go back to natural language. So at times like this, I kind of think as the LLM as natural language to structured data, and then structured data back to natural language, which is kind of cool. I don't have to think about all the API parameters and stuff. I'll show one more because I think this is a really neat example. I actually use this multiple times a day myself since I made it. So if you pull up, Anna, have you ever prompted or worked with someone that was prompting at an LLM and they actually injected links in there, thinking the LLM was actually like going to those pages and reading them, and of course it's not. In most cases, it's not. And the other thing that's tricky is that if you go to gemini.google.com, like we did earlier, that has extensions. So that has things like YouTube extensions and math extensions that call out and do things. And then people go into Vertex AI and they're like, I'm using Gemini and it's not very smart. Like it doesn't have extensions. And I'm like, yes, that's by design because you probably don't want your enterprise, Gemini reaching out to random websites. But you can get those by adding reasoning engine agents, right? And adding tools. So this is a YouTube video in this prompt, 2 minutes. It's from the Major League Baseball in the US. And it talks about how the Major League Baseball uses Google Cloud, which I thought was pretty cool. I always love seeing these like physical use cases of how they do real-time analytics in sports. And so there I see a mention of BQ, and I see like data points, and I have a question. So I say, which Google Cloud products are mentioned in this video? And if I send it that with the URL, on the back end, there's a function that is going to pull the transcript from YouTube. It's going to do that live, and it's going to synthesize that for me and answer my question. So on the left side, I get I don't have access to the internet, which is great. At least it didn't hallucinate an answer, and I know it didn't access it. On the right side, it's like, oh, it mentioned BigQuery and Anthos. And I love it because it's a short and sweet answer based on the actual transcript of that video. And so I actually use this a lot of say, don't tell my manager this, but if we have like a long, team meeting, and I might go in and say, hey, did my manager mention my name at all or something? It's kind of fun to use this and like to do summaries and interact with. Instead of just saying summarize this video, I can actually interact with it and ask questions, right? So I thought it was a cool little demo, and you all can play around. You can please try to break it too. I'm very interested in how people break things, but try things out. Try your own YouTube videos. The document search is based on a vector database with the information from the Google store. You can ask it questions about Pixel Pros and Pixel tablets, Pixel watches, and try things out. You can kind of have fun with this. And these are all little functions that are tools that are calling out to something. And so I kind of think of it as like beyond RAG, right? It's like it's kind of like a RAG, but it's reaching out to other things instead of vector databases. And it's thinking. I could actually, these are simple problems for an agent. I could give it really hard problems and say like, try to solve this iteratively. And then when I give it a prompt, it may actually go and iterate on that 3 or 5 or 10 times to get to the right answer, right? So play with that demo, try it out, and it's a great way, and it links to other docs and source code to be able to build things like this too.
Yeah.
Awesome. So moving on, back to you, Anna, of what you get with Reasoning Engine.
Yeah, so as you saw from the demos here, I think it was a great example. Some things that you're really getting are one, this LangChain template. It's really just a simple framework that really helps you and kind of guides you through this process of building an agent. Instead of writing a whole bunch of code, it just kind of simplifies the process as you saw from those 5 lines before. I think that's great. Simpler is better always, in my opinion. You're also getting agent customization. You're able to really play around with all those different levels. Again, you can swap out different agent types. You can do different prompts. You can even do different models. So So I think that's a really neat control that the developer has. You're not really just glued to one solution, and you're not able to really then move around. And then the last thing is really, you have this deployment capability. It's just a fast way to really get things up in both a secure and scalable way. I think that's a really awesome thing. As we had mentioned before, there can be a lot of, tedious tasks around getting infrastructure up. But, with Reasoning Engine, it's just a very quick deployment. And so that's really great. Again, how we kind of really want to emphasize that this is not like replacing LangChain, but this is actually more of just a way to kind of have a happy path to getting LangChain on Vertex. Any other comments, Chris?
Nope, I love it. That's this is a really, really important slide here of like, what are you actually getting? And we're trying to be super transparent to developers with minimal, marketing speak or other. So you get 200-ish line, which you can look in our SDK on GitHub, LangChain template that just organizes model, function calling and tools, the agent layer. And so there's structure in that, and there's meaning in that. Think back to the early days of models, training a model with scikit-learn or TensorFlow, and it was messy. And then we came up with things like Vertex AI pipelines and Kubeflow. And so that's what this is. This is not in any way like, we love LangChain, we love open source, we love LlamaIndex, and we love developer tools that help you get things done. And so LangChain template, deployment, and customization, like if you remember those three things, that's what we're promising you as developers that we're giving you here. And again, don't take our word for it. Go in our docs and our samples and rip it apart and see. Hopefully you'll be able to see those three things.
And so essentially kind of digging a little bit more technical into it, how exactly do you develop and just deploy these with Reasoning Engine? We saw this a little bit before, but it's just 3 simple steps. You 1, define your functions, 2, you define your agent, and then 3, you deploy your model. And it's really just as simple as that. So we've seen it a little bit more before, but let's move on to some more real-world examples of Reasoning Engine action. I think people are probably a little tired of just looking at currency exchange, since we have that pretty much everywhere. So let's look at some other ways. So first point we really want to emphasize is that with LangChain, with Reasoning Engine here, you really have complete control over the development. Here we have 3 different functions. They're written in Python. We have one for getting directions, one that's translating, and then one that's also pulling from Google Cloud, storage and things like that. So because Reasoning Engine really wraps these existing components in, in this case, LangChain, Gemini and function calling, you just get to control essentially the agent's function, all you have to do is essentially control the agent's functions and tools definitions. Then we're able to just kind of,
Yeah, absolutely. No, this is a big one we hear from developers, is a lot of tools, whether they're low code, no code, or like wrappers, they can often take away control. And so like if you're using the GCS client, for example, it has a ton of options, right? And like anything you use that takes those away is a problem for a developer, right? And so all the point we're trying to make here is Reasoning Engine is using the Vertex AI SDK. You're writing Python alongside your other code, and we're not taking away or replacing any of that. Like all you're literally doing is writing a Python function, and then we're referencing that and using your Python code. And so you don't lose all of those options and ways of authenticating all those settings. Like you still get to set all of those. So that's the point that we're making here. And you know what, Anna, because of time, I want to jump to the second. There's 2 things I really want to show here. One is, how do we go beyond RAG, but still use a RAG and call Vertex AI search? So you want to talk us through this less boilerplate? Because I particularly like this one. I'm not a fan of boilerplate and repeating myself everywhere.
So, Reasoning Engine, it really helps reduce a lot of this boilerplate code. It works directly kind of just with Gemini's function calling to really just invoke the tools without requiring the use of, a lot of verbose prompting templates. You don't have to do manual piping. strings between components, or you don't have to really deal with any of these API specifications. It really helps reduce things, and it kind of abstracts it in a way that's just like more clear. So you only have to deal with essentially the logic and things that you actually care about.
Yep, exactly. And to show that point, let's look at some sample code for. So it's kind of interesting. We talked about beyond RAG, but obviously one of the first questions we get is, I have an agent. Can I make it talk to a vector DB in RAG? Absolutely, right? Like a RAG is a subset or a specialization of this kind of tool calling agent, right? So let's look at an example of that. And all of these code samples are in our GitHub repo, and I'll give you the URL at the end when we wrap up. So stay tuned. You're not going to miss out on that. So there's a sample notebook about building a conversational search agent, Reasoning Engine and Vertex AI Search. For those of you who don't know, Vertex AI Search is like a managed vector DB on Google Cloud. It's one of my favorites because it's like a zero config, or you can go in and do your own embeddings if you want. But you can literally just throw it a bucket of GCS, like a GCS bucket full of PDF files, and it'll go in and chunk them and create embeddings and host them without anything, without any extra work. Or you can make your own embeddings and use them instead. So let me go through the first boilerplate part of this in terms of like the imports and stuff, and then we'll get to the agent building part, this part. So first, we define the generative model. I'm going to use Gemini 1.5 Pro, and then I've created a data store in Vertex AI Search. I created it. One of the samples we have uses the Kaggle Movies dataset, and so I've created a data store that uses that dataset from BQ structured data, and so I'm pointing to that dataset. And now we're into the steps 1, 2, 3. So I'm going to write a Python function to search Kaggle Movies, and this is going to search across the records in the Kaggle Movies dataset. And then here I'm using LangChain again as a retriever. And so this would be the retrieval part of RAG, where I'm basically asking the user prompt and sending that as a query to Vertex AI Search. So we've made our own little RAG here. The only difference between this RAG and one you might implement otherwise is that this has a reasoning layer. So this has a default agent built in. You could swap that out for another agent. You could add to the system instructions, or you could just leave it as a simple agent. So if you run this, just a Python function and then do a sample, like let's search the Kaggle movie dataset for Harry Potter. And because it's structured data, right, it comes back with all of these records. And then this is what we would want to pass to our agent inside of the loop, or rather, this is what our agent would pass to itself as it's exploring this data. The next part is we define a prompt template. One thing you'll notice about Reasoning Engine is it's very modular and very composable. So you could actually run it with like the simplest 3 lines of like no system prompt, no memory, just LLM with a tool. Or you can add those layers. You could swap for a reflection agent. You could define your own prompt template, define memory. And so earlier, we had that runnable message of memory. We handle all of that in our template. And so here we're going to define a prompt template, define a get session history method, and then we define our agent. And now we have the prompt in there. We have the model. We have the chat history. We have the model temperature 0, which is a good idea in most cases here because that's going to drive the temperature or the variation of the tool calling as well as the generated content. So if you're testing and stuff, please, I suggest using that. And then we add our tool. You could have more Python functions here. We have 1, but you could have like 5 or 10 that look at different data sources or different aspects of movies. And finally, we add this agent executor to return the intermediate steps, so we see what's actually going on. And with that, like we have an agent, and now we can test it locally. And I can say, list some sci-fi movies from the 1990s. Of course, it's going to break because I'm giving a demo. Normally, this would reach out to the Kaggle movie data set and run with that. I'll look and see. It's probably something I've messed up in the data store. But once we do that, we can then deploy this. And in about 1 or 2 minutes, like this will live in an endpoint in Vertex AI. And we can make queries against it. And I can pass it to my front-end team. And they don't have to know anything about Python or LangChain or runnable messages with history or any of that stuff. they just send it questions and it gives them answers, and I think it's really smart. So that's a great way to use reasoning engine with a RAG pattern to create this kind of like RAG agent, right? And I like to use the term like conversational search agent, because you're not just like searching, getting results. You're not just doing a RAG and a summary. You could actually ask problems and have the RAG go and try to solve them. Like look up this piece from movie A, combine it with movie B, multiply them, do the, there's all kinds of things that may require more than just a one-shot, request and response. Cool. Okay, so going back to our last demo there, we're talking about fast prototyping. Tell me about that, and then on what you see with customers prototyping and go into production and timelines like that.
Mm-hmm. Yeah, so the third point that we really want to kind of iterate here is, reasoning engine really accelerates your prototyping. You can build faster and explore new ideas without having to wait for connectors, for specific services or APIs. You can just connect Gemini to any API directly with reasoning engine. Before you would have to maybe wait for plugins, but now any Python function can be part of your agent, which is awesome. I think also another thing is in terms of fast prototyping, it's the fast development. If you could use this as either a way to just get your local code out and maybe as a proof of concept, or you could actually even use it as your production application. So there's multiple ways to kind of go with this. But
yeah, totally agree. And I have both worked at startups and both been on the customer side of it, where I'm like, I really need a data connector for this support system or this code repo. And I end up talking to a product manager, and they usually are very helpful and like, yep, here it's out, but like we're still working on it. It's in alpha. We have to do more testing. It'll probably be out in the next quarter. And I'm like, please, I need this connector. And then of course the connector comes out and it doesn't work how I want. And I'm like, oh, you forgot the option. Or anyway, I many vacations later, I will like, okay, finally I have a connector and it kind of does what I want. Here, you do not have to do that. I get asked all the time, how do I make a secure call using custom auth? Just write it. Anything you write in Python, I can make it part of your agent. And so that's one of my favorite parts, is I don't actually have to go pester Anna or other people and say like, Anna, is that connector ready yet? And I'm like, nope, I just write it. And I can call, I can use whatever Python library I want. I can use my favorite SOAP XML library if I want. I can use anything. Like I don't have to wait for that, because this is all happening natively in Vertex, and at the code level, I just write that out. And so the last demo we want to show here is one of my favorites. It uses the Google Maps API, which I think we all may have used at some point for geocoding or places API, stuff like that. And so I want to play around with this and show you a Google Maps agent that I built that I even learned about a new API we had. Anna, did you know we had a solar API in the Google Maps API? How cool is that? It actually gives you the solar flux averaged over time, like daily, weekly, monthly. So you like look at your house and like get the solar flux annually. How cool is that with an API call? So I thought, that sounds awesome. I want to give an agent that and see what it can do, right? And so let me jump over to the last demo and notebook will show. And again, this one is in our repo. The link's coming. Wait for it. You will get it. And this example, I'll jump over, since you already know, since you're all pros now with reasoning engine, you know the process. You could build agents in your sleep. And so now I'm going to initialize this, and we'll import some libraries. There's some exciting ones in here like Rasterio. And for those of you that have done any like imaging or satellite imaging or X-array stuff. So define the model, put an API key. Don't worry, you can steal my key. I'll take it offline later. Then we're going to define 4 functions or tools, right? And so one of them is to geocode an address. You all may have used that before. So that goes from an address to lat long coordinates. There's search places. So this will give you a list of the top K places near a certain place or a certain query. There's a static map. So this will give you back an image of a satellite map or hybrid map or a streets map. And then there is a solar potential map. That's the one. I knew Google Maps had a lot of cool stuff. I had no idea it had this. So this is really cool. This is one of like 25 APIs in Google Maps API. And so this one will get a raw solar information as a TIFF image for surrounding a location using the Google Maps API. Really, really cool. And so those are the 4 tools we're going to give to our agent. And so now let's just do a quick test on those, make sure that they're functioning. So like geocode this airport in Berlin, looks good to me. Places, looks good to me. Static map generation of maybe we want to build. So you know what, Anna, I was thinking of building a solar panel project, and I was thinking of like big open areas. And so on a survey, I was thinking of the airports, right? They have big open areas. And so like I could get a satellite image and start to look around like, hey, there's a big parking garage here. Maybe you've seen the parking garages that have solar panels on top. Kind of cool idea. And so I say, okay, what's the solar flux for that location? And so these are all just function calls. We'll get to the agent part later, but I'm just kind of walking you through when and why you would call these APIs. And there's the solar flux for the Berlin airport. Very cool. So now let's get to the agent part, and we will define our agent. And hopefully you're so tired of seeing this right now. Great. It's such a small, simple way of defining an agent. And we've given it the 4 tools. And now let's test it locally. I want to build a community effort to build a solar panel project near the Tokyo Big Site Exhibition Center. What are some nearby government offices that can help me? So this is doing a places search. Notice that I didn't say, please call the places API for this lat long. Like, it's doing that as part of its tool set. So the agent is thinking, okay, first I need to know what's the lat long of that so I can ask places. So it's a really cool way of how these agents will just kind of use the tools available to solve a problem. Now, let's get to a harder question. Like, what if we wanted to get a satellite map of the area, solar potential to the area? This would do the same thing. And again, we could deploy this. And you'll notice this is actually reading and writing files to GCS. We're actually taking TIFF files and processing them on the client side. So like, you might think of all kinds of cool. I think we're so used to seeing chatbots a lot that I really wanted to change it up with a little bit of, some kind of media, right? Like, let's get images as output, and let's be able to take inputs and outputs like this and think about them. Like, basically think you have little helpers or assistants that are helping you with this solar panel project. And that's what our agent's doing, just with these few little tools. So I use this a lot. It's a lot of fun to just, try things out and see where you go. So take that example, play with it. Very excited to see what you can build. Cool. So let's get into the summary and resources. Anna, you want to talk about benefits and take us out?
Yeah. So, Reasoning Engine offers a lot of benefits. As we've kind of just mentioned throughout this, the 4 key points we really want to drive are, you have full control of the development. You can customize all agent components in a modular way using open source frameworks or your own custom frameworks, or you can use our pre-built LangChain template. A lot of less boilerplate code. You can develop agents without API specs or excessive boilerplate code. If you can write it in Python, you can add it to your agent, which I think is great. Fast prototyping. So you're able to move faster with the LangChain template, as we mentioned before, and you can obviously just go to production faster, deploy and get your app up in just minutes. And then the last thing is, being in the GCP ecosystem, you get a fully managed service with Vertex AI. And so you just need to bring an agent and a list of your dependencies, and we will manage the rest.
Very cool. No, that's exciting stuff. And I think we have some resources for people to get started with. Is that right?
Yeah. So, we've mentioned before, we have a lot of notebooks. We really love people to kind of get out there and test them out. In general, then after that, if you want, we would really, really appreciate getting some feedback. So, tell us about what you like, what you don't, feature requests, issues, all of that. We have a link for that as well. And then lastly, we have some documentation to help you kind of walk through this a little bit more.
Yes, absolutely. And that QR code at the top will take you to that first link of the sample notebooks. I know you all are developers. You're like me. You're like, give me the code. I'm going to tear it apart. Go there. And I promise play with those. And I promise you'll be able to build an agent in like a minute, and you'll have one running, and you'll be able to deploy it in another minute and actually query it. So please go to those samples. Let us know if you have bugs or run into issues. Like, we'd love to hear any and everything on your mind. And then in a few more slides after our Q&A, Willie's going to come back and tell you about some Google Cloud community resources. And there's one out there that I want to call out. It's the forums. So if you're not on the Google Cloud community forums, there's an AI ML subforum, and people like me, Anna, and a whole bunch of other GDEs and champions come in and share their ideas and thoughts there. So please do. So let's get to Q&A, and thank you so much for your time. I saw some questions coming in on the chat. We also had some pre-submitted questions. So Anna, why don't we go through a few of these, and then we'll wrap up for today.
Yep.
Cool. So we had a question about the UI UX for agents, and it's funny, I was just mentioning this chatbots. So we have a question: do AI agents in Reasoning Engine need to be chatbots, or can they work in other ways? Anna, do you want to tackle that first, and I'll come in afterwards?
Yeah, I would say they don't have to just be tied down to just chatbots. They can be really used in a multitude of ways. They can take actions on things. They can actually, besides just kind of talking to you, they can actually like do things. They can perform things. And so I think that's a really cool capability of agents, going beyond that RAG use case. Yeah.
Yeah, you're absolutely right. And I have a theory, like I work in DevRel, and I have a theory that like chatbots are easy to demo. They're very transparent. And so I even, today I even showed some, but I don't mean to say that you should only make chatbots, right? That I think it's easy to demo, it's transparent when debugging, right? And it's fun. But like you could actually stuff this all behind an endpoint. And I've had people ask like, hey, instead of doing this like chatting with your solar planner tool or agent, can it just like come back to me with a report with the top 10 locations? I'm like, absolutely. We do this demo to show like simple tasks to kind of, because we know not everyone, including me, is not ready to go like full agentic right now and like fully automate myself out of a job. I try to do it really hard every day, but we're not ready yet, right? And so we still have these discrete tasks that we do. So simple tasks, automate those, build your way up, and just remember that chat modality and stuff is really powerful for iterating, but you don't have to expose that to the user. You could have multiple chat turns and multiple agent iterations happening on the back end, and you're just presenting people a report or like the results. Like everything's done, the cake's ready. Here's your results. Like that's a nice way to think about it. So great question. Thank you for that. Next question: compatibility. Which LLMs or generative models and versions, because versions are important and they change very often, does Reasoning Engine support? And what about which reasoning frameworks? I'll answer this, and Anna, let me know if you have anything to add. So this is a great question. Out of the box, the LangChain template that we have uses Gemini and Gemini function calling. And so that's around in Gemini 1.0 Pro, Gemini 1.5 Pro, Gemini 1.5 Flash. So generally, those are the versions that are supported. Our docs talk in great detail about that. Of course, you can flip which version. You don't have to wait for us. Like you can flip to a version and use it. Another interesting point is you can actually swap the agent. So you don't have to use our default agent, which is sort of the React type of agent. You can swap that to a reflection agent. You can even go far down as to swap the model. So you could swap Gemini for Claude 3. You could swap Gemini for Llama 3, both of which support tool calling. So it's very exciting times for tool calling and function calling, and all of those models I mentioned, other than Gemini, are in the model garden. And so like you could literally take our example and swap it out. That and reasoning frameworks. So we provide a LangChain template. There's no reason that you couldn't swap out Llama index or write Python code. And so maybe you have your own idea of a reasoning framework. Like that's okay too. We do not restrict you to LangChain. We don't restrict you to like certain things. You can literally rip it apart, even to the point of breaking it, which is okay. We're developers, right? And so we don't want to limit what you can build and versions. You don't have to wait on us. Those are literally just variables in the template. Or you can go templateless and go nuts with hosted Python code and agents. Next question, security. Can I connect to an API with a closed private network, VPC? Can I connect to APIs that use OAuth or HMAC for authentication? I love it. This is the enterprise security world we live in. Anna, before I get into the weeds, like, do you have any topics you talk with customers with security or like, what's the word I'm thinking of? Latency requirements. Like, do they have any of those? I'm sure that they haven't forgotten all about security with Gen AI.
No, definitely. Everyone wants to make sure that their data is going to be secure, or like, they want to be able to access things that, aren't just publicly available. In terms of latency, there's also, a huge concern around that. Everyone wants to make sure that because of, all the turns happen in the background of an agent, they want to make sure that there isn't a big latency issue, especially as they start bringing and scaling this all up. They just really want to make sure that things are tied down well.
Yeah, perfect. And yeah, thank you for the overarching idea, because this is Vertex AI after all, right? And like we have standards and we have requirements and regulatory requirements, governance, privacy, security, and so to the point about closed networks and stuff. So reasoning engine is, like Anna said, it's a few different things. It's the template and the code that I showed you. That's just Python code. So like when you're testing locally, you can run and test that wherever. Again, there's no like reasoning engine master node that needs to see whatever. It's literally LangChain and Vertex SDK. When you deploy, that's hosted on Vertex AI. And if you've ever, I wonder if anyone has ever gone into the IAM view of the Google Cloud Console, and on the top right, so it shows all your IAM accounts and service accounts. And on the top right, there's a button that says include Google managed accounts, and there's a whole bunch of them there. One of them is a reasoning engine, and it's whatever that reasoning engine service account agent has access to, your reasoning engine's agent will be able to access. So something that Anna and I love about all of this is the innovation, but also the like security. We know what's table stakes and we know what, so all of that's there, and you can add, certain roles for reading from BQ or not or whatever. You can add all of that stuff at the IAM level as you normally would. And so you can absolutely talk within a private network VPC, assuming that you configure that in your Google Cloud project. You can absolutely use OAuth and HMAC. Like there's nothing in Reasoning Engine that's going to block you from doing that. So we hope that you could just keep doing what you're doing, add a few layers with Reasoning Engine, and you're off to the races. So let's do a couple more questions and then we'll sign off for the day. Scalability. How does Reasoning Engine handle scalability of AI agents when using LangChain? Long story short here is we are Google Cloud, and scalability is very important to us. You probably noticed that over the past, let's say, decade or two. And so these LangChain agents are running on a serverless platform within Google Cloud. You don't have to worry about like instance sizes and stuff. This is running on an auto scaling serverless platform. And the good thing is, because it's in Vertex AI, like you are just next door to making calls to BQ and GCS and all that stuff. And so scalability is handled automatically for you, and you can try it out. You can either load test the demo app that I showed earlier, or deploy your own agent and just kind of go nuts on it, and you'll get a feel for latency. You'll get a feel. And by the way, we keep saying latency. Reasoning Engine and all this should add like no latency, extra latency to your models. A lot of people get confused and they use these and they say, oh, I made this call to Gemini and then I made this call to Reasoning Engine and there's more latency. Actually, all you're seeing is that there's just iterations going on. It's thinking harder, right? And so it's iterating more with Gemini. And so if you were to do that in whatever you're comparing it to, that's probably making one call. And so if you made as many calls, it's usually the latency is just how many calls to Gemini am I making and how big is the context, right? Anyway, scalability is very important to us. Test it, load test it, break it, and if you find something weird, let us know. We really want to know what your footprints look like for Gen AI apps. So I'm gonna grab one question from the chat. If I can navigate my way around there. There was a nice example about metrics, and I love that. There were actually a couple of questions, one from David and a couple of others. What metrics do you suggest to measure so we can ensure our agents are working properly? This is a wonderful question. We could probably have a whole session on this, but I'm going to give a short answer. And I think that's a good topic, Anna. Maybe we can go into next time. That would be really cool to go like agents eval and all that kind of stuff.
Definitely.
My short answer is any kind of evaluation that you're doing. I've seen customers and users try to do really complex, high-dimensional eval, and it's hard. And so think back to your testing, instincts of I have unit test, I have integration test, end-to-end test. Out of that, I used to get metrics like F-scores and things like that. You don't get those anymore in the LLMs and Gen AI. Someday, some smart researchers from DeepMind or something will come up with metrics for us. But as of right now, you get nothing. But what you should do always is just think about the end user, whether that's your employees or your actual customers. Come up with 10 or 20 or 50 sample questions in a spreadsheet and just run them through your agent, run them through your old way, run them through the new agent, score them, thumbs up, thumbs down. If you don't have that, every little parameter you change, like the temperature, the tools, even a parameter description, can actually wildly change your quality and accuracy. So I think everyone should first come up with like, what do they mean by quality and what do they mean by accuracy, and come up with definitions of those and a rubric. And this could be like a 1 to 10 or 1 to 100. And so quality might mean like, how natural is the conversation? Accuracy might mean how many things in here are right and wrong. And I would even add an extra one, because agents, I would add reasoning capability. Like, what reasoning steps, how many iterations did the agent take? Think of it like you're grading a student's homework and you know they got the wrong answer, but why did they get the wrong answer? Is it because they're a misunderstanding division? And if you can correct that, you can bump the accuracy up for everything. So it's a great question, and I'm so inspired to like do a later session on eval and agents. So stay tuned for that. I wish I could give you answers of like the H score and the Z score or something like that, but I can't. But just make that your evaluation, put it as part of your CI/CD, and then when you get those results, go back and make one change at a time to know whether it's at the model layer, model settings, agent layer, tool layer, agent, like now you have a rubric and a framework to actually make those changes. Anything else to add on that, on eval metrics? I think it's a great topic.
Yeah, no, it's a great topic, as you mentioned, and you could definitely spend another hour just talking about this in itself. There's a lot of, as this has been more emerging, and it's not as, I guess, deterministic as other things, so it definitely is a complicated space. And so, yeah, we appreciate questions.
Yes, absolutely. And so, yeah, that's funny. We'll in the future, we'll have a session on eval, monitoring, tracing, observability, right? These are all the hot words. And so I wish I could spend so much, but we'll take that as a thank you for those questions. So to take us out is Willie. Anna and I want to thank you for your time here. All our wonderful group to work with. We love all the community members here. We hope we've given you a lot of tools, sample code, and ideas, and really inspiration and excitement to like go forth and build more agents and do more cool things. I always like to like prototype in reasoning engine and then like productionize with function calling, things that are more deterministic. I like to use that word, Anna. So on behalf of me, Anna, and the Vertex AI team, like, thank you all so much for your time. Thank you, Willie, for hosting us here. It's been amazing, and may you all have many happy stochastic parrots in your future, and may they be better organized by reasoning engine. So Willie, take us out.
Yes, Anna, Chris, thank you so much. What a great session, super insightful. But let's keep the conversation going. If you're not a member of the community, please join. I'll put the link in the chat once more. If your questions didn't get answered today, go ahead and hop in there and we'll do our best to get them answered. And let us know how we did too. So I will put one more link in the chat. Let us know how we did. Let us know what kind of future sessions you'd like to see. And with that, I will say goodbye and thank you again for everyone who joined.
Thank you all so much. Appreciate it.